Bismillah ar-Rahman ar-Rahim. This is lecture number 2 in the series of the lectures in digital logic design. Today I am going to explain you the concept of the logic gates. First of all, you must know that what is meant by a logic circuit. Every electronic circuit is not a logic circuit. A logic circuit which can perform intelligent operations is called a logic circuit. So a logic circuit may also be named as the logic gates. So if any electronic circuit which can perform a logical operation, or in other words, which can perform intelligent operations, that type of electronic circuit is called a gate, or it may also be called a logic gate, or in other words, it may be called a logic circuit. Now specifically, what is meant by a logic gate? A logic gate is an electronic device used to implement a logic operation. As I mentioned you, by a logic operation mean an intelligent operation. Shortly I will tell you that what is meant by intelligent operation or a logic operation. There are three basic logic operation in the world of logics. That those three operations are the AND operation, OR operation, and NOT operation. So as I mentioned you in my previous lecture, that this digital world is based on these three basic logic operations. But along with these three basic logic operations, we have few more derived logic operation. Like here you can see NAND gate. When you combine the and NOT gate, it gives you the NAND logic operation. So this is another derived logic operation which also forms a fundamental element of the digital world. Next is the NOR. Now this NOR is again the combination of the two basic logic gates, that is NOT gate and the OR gate, and same is the case for the other gates like XOR, which is also called exclusive OR or exclusive NOR. This exclusive OR or exclusive NOR gate is having all the three fundamental gate operations, mean AND operation, OR operation, and NOT operation. It will become clear to you people as we move or as we go forward in this course. In this slide, you can see the summary of the three basic logic operations, which is called AND operation, OR operation, and the others are the derived operation like the exclusive OR operation, the NAND operation, the NOR operation, and the XOR operation. I'm sure that most of you people will know about the truth table of these logic gates. If we start from the AND gate, so here you can see that this AND gate is having two inputs. Let we label the two inputs by A and by a label B. So here you can see that there will be four possible input combination of these two inputs, A input and B input. Now corresponding to these input combinations, this gate produces certain outputs, because here you can see that if you give 0 0, so it will produce 0. If you give 0 1, it will produce 1. If you give 1 0, so it will produce 0. And finally, if we give 1 1, so it will produce 1. Now what is the basic decision that this logic circuit or logic gates can perform? The basic decision that this logic gate can perform, that is basically a recognition of the highest or the lowest state of the input combination. Out of these four input combinations, 0 0, 0 1, 1 0, and 1 1, this logic gates can identify the last input combination, which is the highest input combination, and it is 1 1. So it can differentiate amongst its input. So it is why we can say that this is a logic circuit, because it can make some logical or intelligent decision. And if we come to the OR gate, so again, if we have two inputs of the OR gate, input A and input B, so there will be four possible input combinations. So in these four possible input combinations, the basic decision that this OR gate can make, that is the rejection of the very first state of the input combinations. So this, and it basically accepts all the other input combinations. So because of this recognition, because it can recognize the very first state of the input combination, and it rejects that, and it accepts all the other input combinations. So because of this recognition phenomena, we can say that this OR gate can also perform intelligent operation. Same is the case here for the exclusive OR gate. So if you look at the pattern of these inputs, so there are four inputs combination again. Now here you can see that this OR gates accepts only those input combination in which the number of ones are odd. So here you can see that here the number of ones are odd, so it is one only, so one is odd, so it is why it's accept that. And here mean the number of ones is odd in this input combination, so it accept that. In the last state, you can see that the number of ones are even, it is 2 in this case, so it rejects it. So another name of exclusive OR gate is also an odd gate. Odd gate means it recognizes the odd number of ones in the input combination. So because of this recognition, we can say that this exclusive OR gate is also a logic circuit, or it is also an intelligent circuit. If we look at the basic logic operation of the NAND gate, so we can see the pattern in the truth table. In this input pattern, you can see that out of these four input combinations, this NAND gate only rejects the highest states, and it accepts all the other states. So it can differentiate between the highest state and the remaining states. So because of this differentiation or recognition, this NAND gate is also an intelligent circuit. So another name of these gates is also called as the logic elements. These are the logic elements because these elements can take the basic decisions. If you look at the basic operation of the NOR gate, so better if you put in your mind here. So there are four input combinations. So what type of decision, a basic decision, this NOR gate can take? Yes, if you look at this, you can see that it only recognizes the initial state and it rejects all the other states. So here you can see that it rejects all the other states. So because it can recognize, so it is why this gate is also called an intelligent gate or a decision making element gate. Now if you look at the XNOR gate, so XNOR gate is the reverse process of the XOR gate. As I mentioned you earlier, that XOR gate is also called an OR gate. So this XNOR gate is also called an even gate because it recognizes the number of recognize the input in which the number of ones are even. So you can see here the number of ones are 2, so it recognizes that. The number of ones are zeros here, so 0 is always counted as even number. So it is why it is generating 1. So it recognizes this and it rejects the other inputs. Here you can see. So every gate performs certain intelligent operation, certain decision. So it is why these gates are called decision making elements or logic elements or logic gates. In this slide, I am going to show you a few examples from your life. Here you can see that this is the analog clock. And in this analog clock, you can see that these needles are moving around, and it tells us the time. So if we are required to convert this analog clock to a digital one, so we can convert that clock into a digital clock and it will look like this. Now here we can read the time in through digital values. Those values are the digits. Through these, by means of these digits, we can read the values of the digits. Here you can see that this is an analog voltmeter because this meter can tell us the voltage of a certain signal. If we convert this analog meter to a digital meter, so we will be able to get this meter. Now, the devices which can perform these digital operations, those devices are having the basic elements. Those basic elements are the logic gates. And same is the case for this switch. It is the analog switch, which is a joystick, some type of that joystick, and here we may have the digital button. So through this digital button we can input the data into a digital system. We must also know about the digital logic. Why we call it digital? We mentioned it earlier in our first lecture as well, but let me explain it a bit more. Here you can see that a logic circuit operates on binary values. Binary values are zeros and ones. So it is why, because of this thing, we call it a digital logic, because this logic is operated on the binary values. Binary values are the digital values. Secondly, you can see that discrete elements of information are represented in digital system by a combination of binary values. Let me tell you here that the electronic devices like the diode, if you are talking about a diode, so diode may be operated into two modes. One is the forward operation mode and another is the reverse operation mode. So this device can be configured in two states. So those two states can further be represented by these two binary values, zeros and one. If we talk about certain switch, so switch may be occur in two states. Either it will be in open state or it will be in closed state. So if we represent the state of the switch by means of zeros and ones, so we may configure these elements in a two state. If we talk about the transistor, so we may operate transistor in two states, either saturation state or cutoff state. So this saturation and cutoff state may be represented by two binary values, zeros and one. And if we talk about certain capacitor, so capacitor may be charged, maybe in the charged state or maybe in the uncharged state. So those two states may be represented by binary values, zeros and one. And there are many electronic devices that can be configured in two states. So if we have to take the job of the logic operation from the electronic components, electronic circuits, we have to configure those electronic circuits into two states. So it is why we say that the logical operation are strongly based on the digital values, which are the binary values. So here you may say that the binary value 1 may be represented by a high value and the binary value 0 may be represented by a low value. And this may be vice versa, but the two state of the devices, electronic devices, may be represented by these two binary values, zeros and ones. Further, we can see that binary values represent in digital system with the physical quantities. Here mean this 0 and 1 is represented. This is something, a digital abstraction. It is something lies in our head. Physically, it has nothing to do. What does these values, zeros and one, physically represent? Physically, it represents certain voltage signals or voltage ranges. Here you can see that by high mean, it may be plus 5 volt and by low mean, it may be 0 volt. So physically, it may be 0 volt or 5 volt. So these physical values, voltage values may be represented by the binary values, which are called digital values, zeros and ones. So it is why we call it digital logic. So that's all for today's lecture. I must thank you all for your patient listening. Again, I must request all of you that if you have to hear from me regarding any type of the digital logic circuits topic. So you may ask me that question in the comment. And I would request all of you that please subscribe my channel and press the bell button and share with your friends so that your friends should also take some benefit of these lectures. So your feedback will be highly appreciated. Thank you very much. God bless you. Allah Hafiz.